Okay, everyone, I'm Elena. This is our introduction to machine learning libraries with Spark session. So here is the agenda, quick overview of your new skills, some reminders for your assignment too. We're gonna look at the markdown for Jupyter notebooks. We're gonna look at the parser function, the area in the assignment where most of the students make mistakes. We're going to look at using the pipelines in general, part two assignment tips, and I'm going to give you a totally different example, which is not in the classroom. It's on the Framingham data. You don't necessarily have to do what you will see on your data for assignment. You don't have to do some of the analysis that you're going to see the examples of, but that's something that I want you to work out with from this session, okay? So now let's get started. What new skills you're learning? You're learning the data management. You're learning on how to work in the cloud. So basically, you're not saving the work on your PC anymore. You use the cloud environment, and you're taking advantage of the benefits of working in a cloud. But you have to learn how to manage your resources, right? So in this case, you get 10 capacity hours per month, right? So each time when you run the Spark and when you run the notebook, in fact, when you put the notebook in the edit mode, you start the Spark engine and it starts, the capacity hours are going up. So you have to know how to manage your resources. You have to know how to use the cloud services, right? So, uh, attention, please, at any time, do not put your credit card, okay? Please do not enter your credit card number. You're not gonna get extra hours this way. As soon as you put this credit card number, then your account is gonna be no longer academic. It's gonna be paid as you go, and you no longer might be charged. You're not only gonna be charged, but also I might not be able to assist because I don't have the paid account. I have academic account, and unfortunately, this change cannot be undone. I'm not sure how many times I should repeat this. Somebody does it every semester, so please don't do that. Okay? Now, in addition to not entering the credit card information, you need to make sure that you stop the runtime environment before you exit. Okay, so closing the browser tab does not stop the runtime environment. Last time I showed you how to stop the runtime environment because the thing is, if you don't stop it, it's gonna keep running and it's gonna time out. It's gonna consume all your hours, right? Please do not contact IBM. You need to use the Salesforce to submit the ticket. And if I respond to you, if I solve the problem, if it solves the problem, please say that it resolved the problem. If it did not solve, then we need to work further together, okay? It's also important to upload the data to your project before you create your notebook, right? Please do not delete the object storage, and you don't want to open two notebooks in the edit mode at the same time because you're going to be consuming your capacity hours twice, right? Because you're running it twice. When you run the notebook, it's important not to skip cells. You run all the cells starting from the top all the way down, okay? And the cells must be executed in order starting from the top, okay? And to get the credit for assignment, please make sure that all your code runs and returns the correct results. And I'll show you some of the areas that you need to pay attention to, okay? So, uh, this is a runtime environment. We're using Spark 3.4, Python 3.11. That's the correct runtime that you need to select. Do not choose any other choices. If you do choose another choice by accident, in addition to deleting the notebook, you need to make sure that you stop the environment, okay? Because removing the notebook does not stop the environment from running. Remember in the last session, I'll show you that again. I'll show you how to stop the runtime environment. All right. Now I have to, I'll show you the markdown of the cells. Remember, there are two cells types, markdown cells and the cells with the code that you run, right? So I'm gonna go to here, and for example, I'm just gonna use a different notebook as an example. And unfortunately, to show you this, I need to put it in edit mode. So I'm gonna click here on the notebook, and I'm gonna give you a copy of the notebook. Okay, I'm gonna give you instructor a copy of that notebook, so that way you can study it on your own, right? It opened in a view mode, so now I have to click here, edit, because I was gonna show you how the markdown cells are configured. Okay. So if you're familiar a little bit with HTML, right, there's some similar concepts. You have a one level heading, two level heading. You have the bullet points, right? You have links, two types of link within the document and link to the outside documents, right? So let's see how it's set up. And feel free to reuse the structure when you do the part two. So this is an example that we're going to be looking at, but well, let's see, it's still loading. Okay, here it is. So now, what is this? This is a markdown cell, right? How do you know this is the cell type is a markdown, right? It's not an executable code, it's just the heading. So when I click here, this is a code. This is how you do it. One hashtag followed by the actual text of the heading. So this is a syntax for writing the level 1 heading, right? And in this cell, it's just the text, that's just a description, all right? It's not a heading, it's a regular text. So now it shows us the raw format, and then when I click on this, when I actually run it, it will show the heading, okay? So that's that. Next thing here, this is another heading, table of contents, but there are more than that going on. So this is a level 2 heading. You have two hash marks, right? In addition here, you have links. Those are the links within the document, right? So because what happens is if I click on this link, such as explore data, it's gonna take, it should take me to the session in the document, right? So those are called internal links. But the way it's set up is this. So this is a heading, this is a bullet point. How do you do bullet points? You need, oops, here it is. This here, this, it means that I want to have like a dot bullet point. That's a bullet point type, specifies that. This here, this text is a link, okay? So this is the link text, and this is the anchor. This is a location in a document where I want to go. So if I click over here, come on. Okay, see this? This is the anchor in here, with here, an ID, see that? This is the ID, see that? ID is, link ID is Framingham data. This is what I put here. See, this anchor is copied here, and this is the text. That shows how the link is displayed. All right. So that's how you do this table of contents. So a table of contents, basically, it's a set here of internal links that take you within the document, right? I'm gonna run this and run this one again to make it look okay. What is this here? It's a little bit more complex, but well, first of all, this is just another level 2 heading, right? This one is just an anchor because the corresponding link in the menu will take you to this session. This one here, you will analyze the random sample. So here is the text. Then the text is followed by what? This is the link, right? Link in the brackets. So basically in the brackets, it shows what is displayed. And here it shows where the link actually takes you, right? Next cell is gonna be very interesting. This is a table. How many of you wrote HTML before? Well, basically here, it's nothing but HTML. This is a tag, it starts the table. Then at the end, you're gonna have the closing tag for the table, right? Closing tag. It's gonna be a slash table. This is just the font, 12, etc. Line left. The table consists of rows, right? So see here, table row start, and then you have the table row end. The row contains cells. So the cell is called table data. See this TD and close TD. So this is just an empty cell. In the next cell, you want to show the word variable and you want to show it in bold. Next cell, you want to do the description, also bold. Next cell, I want to put an image, but the image is bigger than the size of other cells in the same row. So what I have to do is, I can say row span 17. So image spans through 17 rows. Last cell in this row spans 17 rows. So it means that the remaining, whatever next 16 rows are gonna have one cell less, right? Because this cell, it spans across, right? What is this? This is an image source. You cannot copy and paste the picture directly. You need to find the image URL online. That's what I did. Images are optional, but if it's something you want to do, you know, but don't spend hours on it, okay? So see, so this is a table. You just add stuff in the table data, all right? So now I'm just gonna make it nice again, okay? So this is what it shows here. I'm just describing the columns that I have, okay? So, well, in Titanic, it's the same concept, all right? But I like to show you the additional example. See that? So this is just the table. It shows you how to create table in HTML, and you can specify the column width. So honestly, I don't like to specify the inches or whatever, but I like to put percentages. That way, the columns will resize based on a screen size, all right? So I use the percentages all the time. Next thing is that big thing that you have to do is the parsing data, right? Well, but before you even do that, do you remember you have to do what? Read the data, right? In this case, I already done reading the data. See that? So if you do run this notebook at some point, this piece here is going to be different. It's not going to be, because see, what is this? This is a bucket name, right? This is going to be whose bucket name? Yours, right? It's not going to be this bucket name. It's going to be the bucket name for your project, right? So I uploaded the data. Then what did I do? I had to go to the code snippets, right? Then I would have to select snippet to read data, right? And then I would have to select my data, which is what? Data set. Well, I'm not going to override the code, but I'm just showing you. And this is the data, right? Okay, I would have to select that. Then I would have to select Spark Session data frame, right? Then insert core to cell. After you do this, you have to change this data frame name, right? Well, you have two options. One option is go everywhere in the code and change the name. Another option is to just change the name here 2 times. What does this thing here do? It's not added automatically. You have to add this. It will make sure that you are reading the actual data type. So if it's a numeric, you're reading the numbers, etc. Okay? So this is important piece here, but there are other important stuff here. So this one, it reads data and it outputs the first 10 rows. If you notice more columns, right? What is this piece here? We start in data exploration, and this is a command called print schema. It's going to output all columns in your data, their data types, And nullable means that if the column may have missing values, right? That's what nullable is. Okay, next thing, I'm just printing the number of rows. See this? This is just to describe another way to see the columns that you have and their data types, all right? But I like the way up here better because it's more readable, okay? But you get multiple ways to do it. This one is just getting the frequency count, and you can see immediately that the data is kind of skewed. You have over 3,000 cases for 0 and 644 for 1. So here it's basically it's predicting if you are at risk. See, if you go to see this description here, right? It's a summary, and you're trying to predict if the person is at risk, coronary heart disease risk. Okay, 1 means at risk and 0 means no. So you need to look at data distribution, right? How many yes cases, how many no cases you have. And in here, you can see sometimes you see if the data is like this, right, and balanced, you may need to go back to your prior coursework and review how to handle it. So that's your homework, right? So that's important. This one, you're just looking at the cross tab. You're looking what else could influence your target, right? So see here, you're trying to look at the education versus the risk. You're just doing the tabulation of how many cases you have. All right. This one is just the breakdown, you plot. Right, so you can see here, see, you have 2 color codes. The orange color code stands at risk, and the blue color code stands not at risk. But you also need to look at the total. You cannot just say, hey, I have about 1,400 people here, right? But you need to also look at how many cases total you have education value 1, all right? So you have to look at the relationships among the predictors to see if predictors are independent from each other. And in this case, some of them are not. Well, if you look at the dataset description itself, right? What do you see here? If somebody is a smoker, and at the same time, it's a number of cigarettes per day. So if I'm not a smoker, number of cigarettes per day is 0, right? But if I'm a smoker, it has to be 1 or more. So you have to decide which column you're going to use, right? Something like that. But there is a very important part here. It's this piece here. What does it do? It's reading, it's taking the file, the CSV file as a text. It's taking the file, it's going to attempt to parse that file 1 row at a time, all right? And this will actually help you. If you here right above the parser function code, if you list all the columns and the column position in the data set. Like see this, the first column is called patient ID, and the position in Python, the positions are numbered starting from 0. So position 0, patient ID, position 1, male, position 2, age, and etc. You do this is going to help you a lot. Now what? Now you have to create something called labeled document. You need to create an RDD, which is a set of labeled documents, in order to run the logistic regression. The labeled document, here you need to pass 3 things. First thing is a unique identifier here. So this is how are the rows in this data uniquely identified. In a person ID, well, this is going to be this one. Patient ID is going to be passed into person ID, unique identifier. Person info, it's going to be the delimited list of predictors. columns that we're using as predictors. Here, label is going to be the columns that we are actually predicting. What are we predicting here? This is a column at position 16. We are predicting the 10-year risk, right? So the output, the algorithm will actually output the percentage, right? It's going to show the percentage, the chance that the risk is 0, the chance that the risk is 1. And the one with the highest risk is the predicted value. So see that you need to define the function that parses. So here is the part that where people get a lot of trouble. So here it's taken, you're sending one line at a time, right? You're splitting it. You're splitting the columns list. If so here what you have to do is you need to look at the target, the column that you're predicting. And you have to set it either 1.0 or 0.0. So what it says here, if the value is greater than 0, then it's 1.0. Otherwise, it's 0.0. Okay? So this will be passed into where? Into label, right? We know what will be passed into a person ID because it's identifier column at position 0. And what is in the middle? You need to create this delimited list of columns that are not the unique identifier and that are not columns that you're predicting. And I tried play around with multiple combinations here, right? But first, you're gonna try to take all of them and see what happens, right? See, in this example, I took all of them. And this one, it returns a label document, but there is another step in there where you are calling this parser function. You need to remove the column headers, okay? So here, where you call in this function, right? So, oops, here, this is just, yes, this is to parse the data, but see here, it just spitting out the total number of records. Oh, see this here? This is just to read, it's reading the file. And if I scroll down, see this is where it's actually parsing it. What is this? It's gonna look at this. We need to somehow, we have to skip the first row. How do we do it? One of the cells, see the very first row, it contains the column heading. So if this is the row with column headings, then it's gonna contain something like patient ID text, right? So here, just using a lambda function. So it's saying that we want to keep everything, all row. If the row doesn't contain this word patient ID, then we want to keep that row, okay? And here, this is calling the parse document function. Remember map here? And it's calling the function that you define yourself, right? Then creates a data frame of all those records. Here, you're printing the number of records in the data frame, and you're outputting the first 5 rows. Here, this is important. You have to check, right? If you see the column headers in the first row here, it means that you did not remove them correctly. Sometimes you may have copied the example code as is, and there is no name column in this data, right? Something like that. Or sometimes you may have misspelled it right or incorrect case, okay? So you have to look at that. Now take a look at this. See this label equals 0.0. It means that this person in question is not at risk. Label is 1. It means that the person in question is at risk. All right. Now what we do here? We're going to split data into training set and test set. As you may remember from your other coursework, we use the training set to build the model. Then we use the test set to evaluate the model. And you can play around. You can do 80% and 20%, or you can do 70% or 30%. I'll let you play around. But this is showing the first 20 records in the train set. Okay? So I know you cannot preview all of them, you just preview first 20. Here you build in the logistic regression model. So you have this tokenizer. Okay, you specifying the output. And see, so this is called logistic regression function here. It's using a pipeline. Now here it's just building a model and you see the stages. Then what you do is you predict for the test data. You evaluate the model on the test data, right? Then you also want to look at this. It's not quite confusion matrix, but you want to check of how many cases were predicted as at risk that are not actually at risk, how many not at risk are actually at risk, right? You want to look at that, and how many were predicted correctly. So you are trying to tabulate a predicted outcome versus actual outcome, right? It's close, but not quite. Then you have to also compare with the accuracy for the test set. Because if accuracy for the training test is 95% and test is only 50%, we have a problem. Your model overfits the training data, okay? So, and you are asked the question about overfitting, it's a review question, okay? So this is just shows the number of people at risk, predicted not at risk, and etc. It's a tabulation, okay? Because see, you have to look at the accuracy here. So we're evaluating the model, we're doing the accuracy, we're doing the F measure, we're doing the area under the rock curve. You want to look at the precision, recall all of these metrics. So that's your homework. To review that and to apply these concepts to the model evaluation. All right? Well, don't we may ignore this warning. It's something that's going to be deprecated later on. Okay? And is this it's evaluation for the training data, 96%. Now you're gonna go here and you're gonna evaluate it for the test data, and you want to also look at the area under the rock curve. All right. But here, something to keep in mind. If your area under the rock curve must be between 0.5 and 1. If not, then we need to go back to the drawing board and see what we did wrong in the code, okay? And this is just the rock curve plot, right? You're gonna have a copy of this example, but I also added some more here. What else did I add? Well, this is just a visualization. This one, it just shows the average age of patients who are at risk and who are not at risk, right? I did some age distribution here. This here, it shows, it's one way to check if the data has missing values. So what it's doing is that it tries to count the number of missing values in each column. So all of the zeros, it means that each column has all values. There are no missing values. Well, I know that they're not, but I need to show you how to check, right? So this one, I'm checking data types again. What is this? Do you remember that summary from number summary, right? So we want to see the mean age, the minimum, the maximum. And all of a sudden, if you see that the maximum age is lower than the minimum, more likely you read the data incorrectly. You want to analyze the value, not the ASCII value. So, very important, if you missed that line of code in ForSchema at the time when you read the data, then your numeric columns could be read as the characters, and you'll be analyzing the ASCII value instead of analyzing the actual values, okay? Just know that piece. What is this? Those are just the histogram, but take a look. I have a lot of columns in this data are numeric. I can do it one at a time, but for you, I found this example where you can take, because all columns in the data are numeric. So what you do is you just pass the data frame, you pass the list of columns, you specify the number of rows and number of columns, and see this, I want to show that like this. All columns on a single chart. See that? I just want to do it in a single block of code. So you're just doing it, iterate through each feature, and it's going to show this distribution, okay? But of course, patient ID, it's an ID. So it's just a single column, right? So this is just one way to show this, and make sure that you import in the libraries. This one, the NumPy, and what's it called? Okay, so you need to import the correct libraries. Sigma something. I'm not sure in the slide. I keep forgetting how to pronounce it. Okay, so we talk about the parser, we talked about the pipelines, we talk about this info schema. This is the data that we're looking at. This is a data set of Matplotlib. You need to include the Matplotlib library. See, that's a library that you need to have. And there is another library, Seaborn, yes. So this library is if you want to show the heat map, the correlations. See that one? So this is a bonus example. You don't have to do that in your assignment, but it's just something for you to take with you as an additional example, because this session should not be a repeat of what's in the classroom. That should be, it should add to what's already in the classroom, right? So this is just, see that, and I specify that I want to do green, right? But if your column had categorical data, you could probably add some code to check the column data type and only visualize it if it's numeric, right? Because if you try to do the histogram on categorical data, you're gonna get an error. It's only for numeric data. Remember that, right? So that's my plot. It says something will be, this one, it says something will be deprecated, the pair plot, but it still worked in this version of the Spark. Oops. Well, forget about it. Not sure what's going on, but let's move on. Okay, so this here, oh, it's deprecated. Okay, my fault. I did not edit the code for this version of the Python, but everything else worked. Trust me, everything else works. So here it is. What is this here? This is a correlation map, right? I have a list of columns from top to bottom and also from left to right, right? I'm listing all the columns and I want to show if the columns are correlated. Remember that the correlation runs from 1 to -1. In this case, of course, the column is correlated to itself. That's why it shows 1. But you can see here that the cigarettes per day is, of course, it's correlated with if somebody is a smoker, okay? So probably you want to keep 1, but not both for your analysis. You might be looking at this one here. So this is one is the hypertension. And you look at this, you need to look at the intersection of the column and row, all right? So this is a systolic blood pressure. Of course, it's gonna be related, right? And usually, if your systolic blood pressure is high, your diastolic is also gonna be high. So something to keep in mind, right? So you want to look at the correlation, and you probably want to check if two columns are correlated. You probably want to pick one or the other, right? Because you have to deal with what's it called, multicollinearity, right? Right? You want to avoid the predictors that are dependent on each other, okay? And especially if you're going to discuss alternative methods, you need to discuss alternative methods that you would use in your data. If you discuss naive Bayes method makes an assumption that your predictors are independent, okay? So I discussed this, right? What do I need to do? Very important. I forgot to do something important. So right now, my engine is running, right? What do I do right now? I have to turn off the kernel. So I'm just gonna shut down the kernel to stop consuming the hours. And that's it, right? So how do you exit? Oh, you stop the kernel first, right? If you're done with working on the notebook, you're gonna go in here and you're gonna save, you're gonna export the notebook, save notebook as, and you're gonna download the HTML, okay? Then HTML can be saved as PDF. So it's the same steps as in your last assignment. I'm done with this, I go back to my project, but I need to be totally sure that nothing is running, right? So what do I need to do? I need to go to here and I'm go to the environment, administration environment. They keep changing it all the time. Environmental runtimes. And I want to check, make sure nothing is running. So now I used 1/2 of capacity hours, right? Oh, I used some last time, but this hours keep going up. All right. Right now I have nothing running, so I'm all clear. It's better to check it 5 times than to miss it and lose your hours. All right. So what's gonna happen is you check how many hours you have left. And I did say, does say if you have less than 5 hours, the TA needs to be aware, and I'm gonna work with you. I'm gonna ask how far you are in the assignment, right? Have you done part 1 of the assignment? Because I know that part 1 should not take more than an hour or half an hour, right? So you will have to download the output for part 1. And then suppose that you have 1 hour left. It depends how much you have left to do. Because even if you have like 30 minutes or 10 minutes left, you will be able to start the service, all right? But you won't be able to start the service again. So if your 10 hours run out while you are working something during an active session will continue running. However, you will not be able to restart the service again until next month. Does make sense? And I actually experimented it, well, not experimented, but I assisted the student who had very limited time to finish the part 2. So I guided her. She actually went over the limit, but because her session was active, it let her finish it, but she could not start the session again until the last month. But I got her to the point that she could submit something, all right? Suppose that you ran out of hours for part 2, but you got your part 1 done. Well, I was a student also. You have something to start the write-up, right? Do not wait until next month in this case. You have part 1, you need to do the write-up. You have part 3 where you don't need to have access to your to IBM Cloud or to data platform, right? You don't need to have access to do the part 3 of the assignment. Mainly those research questions are for review, so you can do that, right? Uh, just try to use your hours wisely. Sometimes it helps to write the code somewhere else, to prepare the code, and then try to run it. If it does not work, immediately stop the kernel and try to troubleshoot. And when you come back to the notebook, after you edit the notebook, what you need to do, remember, you need to restart the kernel and clear the output, right? You have to restart it from the beginning and clear the output. Remember that. So this one is just showing you how to save the notebook. You just save it as HTML, and then you can print it to PDF. Sometimes there is an option to save to PDF directly, sometimes there is not. So yeah, you do it based on that. This is another example of the using pipeline for logistic regression. They're trying to predict if the heating and air conditioning system is working correctly. All right, they use logistic regression to do that. So this is another example, but it's not as detailed as what I showed you here, but it's just something else to look at. Okay, now I'm gonna see what questions do you have, guys. Everything good so far? You submitted the, yeah, go ahead.
Good afternoon, good evening, rather. I have a question.
Uh,
We're all the side of the check to when we do
uh,
when we do this practically.
what?
So when we're, excuse me, hello?
Yes, yes, I'm here, I'm
Yeah,
listening.
okay. So
Mm-hmm.
when we're doing this, should we use like the same project or do- and just upload the, one of the documents?
Oh,
Oh, yeah, I'll set it.
well, what are you asking about the part two of the assignment?
Yeah, yes.
Oh, part two, you can do the whatever way it works. You can
Okay.
do it from scratch, or you can just take whatever I gave you, whatever you have for part one, and update it for the part two code, right? But
Okay.
yes, but you have to edit the code in light of the example you're looking at. Because what's gonna happen if you take the Titanic code as is, right? You're gonna be predicting if mother is a smoker instead of predicting if the passenger will survive. See, Titanic data it predicts if the passenger will survive, right? This is
Mhm,
how the columns are positioned. Survival. This is column at the position 4,
mhm,
right? But if you take this and if you copy the parser function as is, right, you're going to be predicting if mother is a smoker for the low birth weight. But that's not what you want to do it, right? It's not the purpose of the data. Then,
okay.
yes, your result is going to be incorrect. And if the result is incorrect, your analysis are going to be incorrect, right? So do not
Yeah.
take that.
Okay.
Yeah, because some students have done it in the past. They took that code, copy and paste, and then what? Well, it's not just the grade. It wasn't the grade. It's about not getting the correct result, not getting what you expect. It's not getting the right output, not getting the right experiment, if you will. You know what I'm saying?
Yes.
Yes. And you asked to do just logistic regression, nothing else. But uh, the theoretical part is to discuss what other method you could use.
Mhm,
Naive Bayes, yes, you can choose naive Bayes. You can choose their options, decision tree, right? Neural network. So just try to explain why. And remember the assumption of independence for naive Bayes, right? The assumption is
mhm,
predictors are independent, right? So just keep that in mind as you researching it.
mhm. Thank you.
Sure, sure. So basically, you know that right by now. If you just present the output, if you don't put analysis, then it's gonna be like a B, right? Well, if you present correct output, no analysis, it's a B.
Yeah.
But still, yeah, you need to explain. You need to write as much as you can. Well, sometimes less is more, but you need to be to the point. You're not gonna go like 1,000 pages, but you want it to be relevant and you want to show analysis. Like if you say that I believe naive Bayes method is going to work, you need to explain the why. How would you use it? It's a theoretical. But another thing, if you notice that if you look at the Titanic data, name column is not used in analysis. Why is that? Because it's a name. It's a personal identifying information. Not quite. It's not a unique identifier because you can have more than one person with the same name, right? But names are not used as part of the analysis. That's why it's not, when it's creating the delimited list of columns, it omits the name, okay? But just make sure to save yourself a lot of time, you do write in that cell where you write the parser function, list the columns and list their positions. That is going to save you a lot of time, trust me. And remember, in Python, we start from 0. Okay? Yeah, I
Thank
know
you.
yes, it's a little bit complicated, but I know you can do it. So I'm confident that you can do it. Anything else, guys? I'm trying to help you. Oh, before I forgot, take a look. This is how it's gonna work. You have this assignment, right? Next assignment is gonna be DB2 and R. Two parts, the big parts. Well, there is a pre-assignment, sentiment analysis tutorial, but it has a part where you use DB2. Was that part? No capacity hours. You can use whatever, day and night, unlimited. For R, it's gonna take 1 capacity hours. As of last semester, it took 1 capacity hours per hour. I'll have to check. So what's gonna happen is that, suppose that you submit this assignment next week. So next week is, what date is it? It's due on 24th, right? So you submit the assignment. On 25th here, that week, you start working on sentiment analysis tutorial. Don't panic if you're out of hours at that time, because you have the DB2 part. You can start with DB2 and do that. Then on Monday, on the 30th, late on Monday night, you're gonna be credited up to 10 hours again. So you will have capacity hours for July to work on the next assignment, all right? Also, remember that if you don't get the work done this month, the hours that you have not used do not carry over. So see that that's the thing. You want to take advantage of hours, you don't want to waste them. But remember, they don't carry over also, right? But if you're doing it right, you should be good. All right. In the past, yes, every semester at least 1 or 2 people run out of hours, because what they do is, okay, I can demonstrate what they do. So they started the notebook, right, in edit mode. Then their friend calls them. They go on the phone, and while they talk on the phone, what happens to this? These hours here go up and up and up and up and up, right? So I recommend doing the work at the time when you're less likely to be distracted, because you want to see. The thing is, if you're while you're speaking on the phone or while somebody distracts you, the hours keep running and you might forget to shut the kernel. And if by accident you close the tab, what you can do is you log back in. As soon as you remember, log back in, go to that manage page, environmental runtime, and see if anything is running and stop. Okay, as quickly as you can remember, jump and stop. Okay, but if you do have only 5 hours left, then I need to work with you. What we can do to optimize the hours, I cannot add the hours, but I can suggest what we can do to use the remaining hours effectively. I'm gonna ask if you've done part 1. I'm gonna ask if you started part 2. Which part are you at? Things like that. All right, then we have a plan on what we can do together to make sure that you get it done. All right, but it's both parts. Both people need to, you need to work with me, I need to work with you. It has to be both parties willing to work. All right, so you're gonna get this recording and you're gonna get the copy of data and you're gonna get the notebook. So maybe later at your leisure you can run it perhaps, right? So you're gonna get that. I'll give you the copy.
Thank you.
Anything else? No? Going once? Going twice? Well, if we're good, then I'm gonna stop sharing and well, in about couple weeks, we're gonna have a next session on the DB2, okay?
Okay.
So, stay tuned, okay?
Yeah.
All
Thank
right.
you so much. And have a wonderful evening.
Thank you. Me also. Thank you.